How to Heal the Universe, Javi Gonzalez and the Search for Einstein's Ripples in Space-Time. About 100 years ago, in the German city of Berlin, a scientist named Albert Einstein searched for the secrets of the universe. First, his thoughts turned to motion, time, and space. Everything in the universe moves through space. A dragonfly, for example, darts forward and backward, side to side, and up and down. As the dragonfly moves through space, time passes. Einstein understood that space and time are linked together, weaving an invisible fabric around the dragonfly. For that reason, the dragonfly doesn't just move through space, it moves through the fabric of space-time. Next, Einstein's thoughts turned to gravity. Gravity pulls things down toward Earth. It keeps the resting dragonfly from floating off into space. Gravity also keeps the Earth and other planets in orbit around the Sun. Einstein wondered what caused gravity. He questioned, predicted, and calculated, until he arrived at a beautiful solution. Gravity is caused by a turbulence of space-time around large objects. Just as a lily pad turns underneath a frog, space-time turns around the Earth. If the frog on the lily pad jumps up and down, the energy from the jumps causes ripples throughout the lily pad. Einstein wondered if energy from colliding stars could cause ripples in space-time. He returned to his calculations. The following year, Einstein announced that space-time could indeed ripple, but he concluded that the ripples would never be detected. They would be much too faint to hear by the time they reached Earth. Without a way to hear ripples in space-time, people consider Einstein's idea simply a fairy tale. About 50 years later, on a warm night in Argentina, beneath the moon, the stars, and the sky, a young girl named Gabby Gonzalez looked up. She too wondered what secrets lay beyond the stars. Each year, Gabby and her family went camping. Far away from the city, the stars shone brighter, and Gabby's curiosity grew deeper. In school, Gabby learned about physics. The science of energy and motion attracted her like a magnet. Gabby thought physics could help answer questions about the universe, just as Einstein had. When she went to college, Gabby learned about Einstein's ripples in space-time. Scientists had tried for many years to find them, but they only heard background noises from crashing waves, distant winds, and passing trucks. Ripples in space-time remained just an idea. After college, Gabby moved from sunny Córdoba, Argentina, to snowy Syracuse, New York. There, she worked on ways to better understand space-time. Gabby found her new work exciting. When she missed her family and friends in Argentina, she imagined they were all connected by space-time. Soon, Gabby met a new professor working on hearing ripples in space-time. She looked at the opportunity to help hear the distant universe. With his help, Gabby set out to tackle the problem of background noise. She spent long days and long nights, counting, testing, and measuring. Gabby's work brought the world one step closer to space-time. By this time, scientists were ready to build two big machines called LIDO, which should help detect space-time ripples. One will be built in Hanford, Washington, and the other in Livingston, Louisiana. The LIDO project needed experts to help predict and remove background noise. Looking for Lido, Gabby was ready. As the team learned to predict different kinds of background noises, Lido became even better at hearing faint signals. Years passed, and the Lido team grew to include over 1,000 people across the world. Finally, it was time for Lido to begin its search for ripples in space-time. But first, Gabby's group needed to make sure that background noise wouldn't keep them from hearing the ripples. They created different noises to see how Lido reacted. The storm rattled and rolled, running tests late into the night. The team decided to finish the tests the next morning, so I left the instrument on overnight. Suddenly, in the early morning, the Lido Livingston detector chirped. The Lido Hanford detector chirped 7 milliseconds later. The next day, Gabby awoke to an alert from Lido. Could it be? Right away, Gabby and her team studied the waves that Lido detected. They measured and remeasured, calculated and recalculated, analyzed and reanalyzed until they were certain of what they had found. Ripples in space-time caused by a collision of two black holes. A long time ago, in a distant universe, two black holes circled each other, moving faster and faster, until it collided to form a larger black hole. The energy released caused space-time to ripple, just like the collision of the frog and lily pad causes ripples. Those ripples moved toward Earth over time, and more than 1 billion years later, they passed through Lido. Over 100 years after Einstein's prediction, Gabby and her Lido team proved him right. With a new way to hear the universe, we can now uncover secrets one ripple at a time. The end.